1943. World War II is happening. Penicillin was just discovered. The first programmable computer is still 2 years away. And somewhere in Chicago, two scientists are staring at the human brain. Not literally. That would be a different kind of show. But they are looking at it. Really looking at it. Asking a question nobody had thought to ask before. Now, to be fair, humans have always had a complicated relationship with their own brains. They used it to write symphonies. They also used it to invent the Tide Pod Challenge. So the organ itself is clearly not the problem. The question is what it's made of, and how it works, and whether, and this is the part that changes everything, you could build one. From scratch. Out of math. And this is where everything gets very strange. The strange idea proposed by two people who should have gone outside more. In 1943, a neurologist named Warren McCulloch and a mathematician named Walter Pitts published a paper. The paper was called A Logical Calculus of the Ideas Immanent in Nervous Activity, a title so dense it could stop a bullet. But buried inside that title was a very simple idea. A dangerous idea. McCulloch looked at the brain and said,
"You know what a neuron is? It's just a switch."
Hey. What? Neurons, for people who skipped biology and have no regrets. Quick biology lesson. The brain is made of neurons. About 86 billion of them. Each neuron receives signals from other neurons. It collects them, adds them up, and if the total hits a certain threshold, it fires, sends a signal forward. If not, stays quiet. On or off. Fire or don't. That's it. That is the entire operating system of the human brain. The thing that wrote Hamlet. The thing that invented jazz. The thing that, this morning, forgot why you walked into the kitchen. All of it. On/off switches. 86 billion of them. Talking to each other. McCulloch and Pitts looked at this and said,
"That's not biology. That's logic."
Which is either the most brilliant observation in scientific history, or a very alarming way to think about yourself at 2 a.m. Possibly both. How you build a brain on paper with no budget and incredible confidence. So they built a model. On paper. No computers yet, remember? Just math. They created artificial neurons. Little mathematical units. Each one does exactly one thing. Collect inputs, check if they cross a threshold, then fire. Or don't. Simple. Almost insultingly simple. But here's where it gets interesting. Connect enough of these units together, and something unexpected happens. They stop being simple. Layer 1 detects basic signals. Layer 2 combines those signals into patterns. Layer 3 combines the patterns into something more complex. By the time you've stacked enough layers, you're not looking at switches anymore. You're looking at something that can recognize. Something that can decide. Something that behaves, in a narrow but real sense, like it understands. From on/off switches. Millions of them. Doing almost nothing. Together. It's like discovering that if you get enough people to hum slightly different notes, you accidentally get an orchestra. What this actually meant for everyone who enjoyed feeling special. Here's what McCulloch and Pitts were really saying. Intelligence is not magic. It's not a soul. It's not something mystical drifting through the cosmos waiting to inhabit the worthy. It's math. Very complicated math. Running on very simple pieces. At very high speed. This is either deeply reassuring or deeply unsettling, depending on how attached you are to the idea of free will. The paper was published. Scientists read it. Mathematicians read it. Philosophers had a very long, very quiet lunch. And then, mostly, nothing happened. Because 1943 had some other things going on. The man who built the first learning machine and then told everyone about it immediately. Enter Frank Rosenblatt, 1957. Psychologist. Cornell University. Extremely good at making announcements. Rosenblatt took the McCulloch Pitts idea and did something audacious. He built it. Physically. He called it the Perceptron. Here's what made it genuinely remarkable. The Perceptron didn't follow rules. You didn't program it by saying,
If you see this shape, call it a circle.
Instead, you showed it examples.
A circle. Not a circle. Circle. Not a circle.
And each time it got it wrong, it adjusted. Tiny adjustments to tiny internal weights. A little more sensitivity here, a little less there. Until, gradually, with enough examples, it got it right. A machine that learned from its mistakes. In 1958, before the moon landing, before pocket calculators, before anyone had a computer in their home, a machine that learned. The press release, a masterclass in getting ahead of yourself. Rosenblatt, understandably excited, told a reporter that the Perceptron would eventually be able to
Walk, talk, see, write, reproduce itself, and be conscious of its own existence.
The New York Times covered it. The Navy funded it. Everyone clapped. It could recognize simple shapes, slowly, if the lighting was good, and you were patient, but the energy in the room, immaculate. The problem with being a genius in the wrong decade. Here is the issue. The Perceptron worked, genuinely, for simple problems, but the moment the problems got harder, it collapsed. Here's why. The Perceptron was a single layer, one set of neurons, one decision. That's enough to tell dark from light. It is not enough to tell a cat from a dog, or the letter A from the letter A in a slightly different font. To handle that level of complexity, you'd need multiple layers, neurons feeding into more neurons, deep stacks of them, learning different features at each level. That's called a deep neural network, and the math to train it properly didn't exist yet. The computers powerful enough to run it didn't exist yet. The data you'd need to feed it absolutely did not exist yet. The entire idea was correct. It just arrived 40 years before everything it needed to actually work. Like showing up to a party at 6 p.m. when the invitation said 10. Technically not wrong, but very much alone. The book that killed the party. 1969. Two MIT mathematicians, Marvin Minsky and Seymour Papert, published a book called Perceptrons. Very mathematical, very thorough, very specifically about everything neural networks could not do. They proved, rigorously, mathematically, that a single-layer perceptron couldn't solve a huge class of problems. Problems that seemed basic, like figuring out if two inputs are different from each other. Which, to be fair, is also hard for some humans before 9 a.m., but still. The book was devastating. It didn't just criticize the perceptron, it made neural networks look fundamentally broken. Researchers read it, funding committees read it, and one by one, people walked away. Rosenblatt pushed back, loudly. He said the critics were wrong. He said the future was neural networks. He said the layers were coming. He was right. He was also, tragically, 30 years too early. He died in 1971. He never saw what came next. The idea goes to sleep. After the book, after the criticism, after the AI winter froze everything anyway, neural networks were quietly shelved. Funding went elsewhere. Researchers moved on to things that worked. The idea of artificial neurons, of intelligence built from simple connected switches, was filed under interesting, probably wrong, check back, never. The shelf was dusty.